Okay. The next module is the operating system basics, module 5. So here the operating system, uh, we will see the basic concepts that are required for designing an embedded applications. We have seen in the previous module that um, embedded systems, few embedded systems may require an operating systems. So in that case, how to design an operating system for such kind of application. So this operating system, whatever we are discussing now, they are not for the complete general purpose system. It is for the embedded systems. Now let's see. The operating system acts as a bridge between the user application tasks and the underlying system resources through a set of system functionalities and services. So it acts as a bridge. It acts as an interface between the user applications and the hardware. System resources are nothing but the hardware through a set of functionalities and services. So this acts in between the user and the hardware resources. The operating system manages the system resources and make them available to the user application task on a need basis. So the operating system is responsible to take care of all the system resources. So what do you mean by system resources? We will see in the next slides. It manages all the resources, and whatever is required by the user, it will provide all the informations, and it will bridge the gap between the hardware and the user application. The primary functions of an operating system is make the system convenient to use. So all of you know the advantages of operating system. We are seeing our Windows operating system, Linux operating systems. Definitely, the operating system makes the entire system convenient to use, and it organizes and manages the system resources efficiently and correctly, as discussed in the earlier point. Now let's go to the next point. Now these are the different system resources, like user applications are the one at the user end, and these are the underlying hardware. Now there are many parts of the resources, like the memory, process, time, file system, IO system. Now all these things put together, we call that as kernel services. So you can see here, between the hardware and the user application, you have kernel services. This is nothing but the operating system. Now, the operating system is responsible for performing memory management, process management, time management, file system management, IO system management. Now, between the kernel services, that is operating system, and the hardware, there is one more application, that is device driver interface. This I had discussed in the class also. So device drivers are the one which makes the hardware to make it makes the hardware to work compatible with our user application. There are many add-ons. Whenever there will be a standard operating system, but when we start enhancing the hardwares, you're trying to connect new hardware. For example, a system is designed to work only with printer. Now you want to connect scanner. So the scanner may not be detected by this operating system. So for that purpose, to detect scanner, we add one more interface called as device driver interface. So this interface is only for the scanner. So in that situation, the scanner can be attached to the system, and then the user applications can use it. So for those kind of application which is not supported by the uh, operating systems, inbuilt operating systems, for them we give an add-on, and this is called as device driver interface. Now coming to the different applications, you're seeing here memory management. So this includes your secondary memory, primary memory management. You would have studied paging techniques, segmentation techniques, all that it has to be controlled by this operating system. Process management, the process ID, process creation, program under execution is process management. This you would have studied in your operating system. So for any program, there could be several processes, so that it has to be managed. That is controlled by the operating system. Time management, what is the time duration for every operations, that has to be managed by the operating system. File system management, we create so many different types of files, the user IDs, its permissions, and where to store, all of them has to be managed by the operating system. And IO system management, as usual, we know that any system requires input output. It may be only input or output or sometime both. So even that has to be made compatible with the user application. So for all of them, the programs are written. These are also type of programs, and these we call it as kernel services, which is nothing but part of the operating system. Now, between this and the user application, there are application programming interface. So, to invoke those functionalities, we call the application programming interfaces, called as APIs. Let's go to the next slide. Now, what is the kernel? The kernel, as discussed in the earlier slide, it is a core of the operating system. It is responsible for managing the system resources and the communication among the hardware and other system resources, as discussed earlier. Kernel acts as an abstraction layer between system resources and user application. So it acts as a layer between the hardware system resources and the user application. Now, coming to the kernel, provides different services, like as discussed earlier, process management, primary memory management, file system management, IO device management, secondary storage management. So you can see here, this is primary and this is secondary. Also, it has to provide protections to all the uh, user files and the system files. So there will be software to protect those files, time management, and the interrupt handling. Very crucial part of operating system, that is interrupts. So it has to be handled. So all these services are provided by kernel. So for a general purpose operating system, all these things will be present. For embedded system, it may require few, it may not require few. That depends upon the type of applications. Now, let's see the next slide. The program code corresponding to the kernel applications are kept in the continuous memory of primary memory and is protected from unauthorized access by user programs. So the program code corresponding to the kernel application. So the kernel are mainly present in the primary memory, and it has to be protected by unauthorized access or user programs. Now, the memory space at which the kernel code is located is known as kernel space. So the memory where it sits, in the primary memory, kernel is allocated a space, and we call that as kernel space. And all user applications are loaded to a specific area of primary memory, and this memory is called as user space. The memory which holds kernel, we call it as kernel space. The memory which holds the user programs, we call it as a user space. Now let's continue. The partitioning of memory into kernel and user space is purely operating system dependent. So this is one thing you have to understand. The partitioning of memory into kernel and user, and it mainly depends upon operating system. So how much memory from which address to which address it should be kernel, and which address to which address user space is decided by the operating system. An operating system with virtual memory support loads the user application into its corresponding virtual memory space with demand paging technique. This you would have studied in operating system subject. So if it supports a virtual memory, then whatever the user applications are there, it will put dump into the virtual memory space. And how it gets swapped, demand paging technique. Would have seen that. Most of the operating system keep the kernel applications code in main memory as discussed, and it is not swapped out into the secondary memory. So the kernel, usually it will be in the main memory, and it will not be swapped back to the secondary memory. So it will be in the main memory. The kernel part will be in the main memory all the time. Now let's go to the next slide. Okay, let's discuss the different types of kernel. So one is called as monolithic kernel. What is monolithic kernel? All kernel services run in the kernel space. Whatever the services we discussed earlier, it will be in the kernel space, in the main memory. Now, all kernel modules run within the same memory space under a single kernel thread. So one thing, whatever the modules we discussed in the second slide, all of them will be under a single kernel thread. So all those services will be put into the same memory space. One memory will be allocated, and all the services will be, means all the programs will be dumped into that called as kernel space, and they run under a single kernel thread. That is called as monolithic kernel. Now, the tight internal integration of kernel modules in monolithic kernel architecture allows the effective utilization of the low level features of the underlying system. So it is tightly integrated. So it definitely allows the effective utilization of the low level features. It will effectively utilize all the features of the underlying system. Monolithic kernel has an advantage, that is, it will effectively utilize the low level features of the underlying system. Let's see in the next slide. The major drawback of monolithic kernel is that any error or failure in any one of the kernel modules leads to the crashing of the entire kernel application. So we saw the kernel has got so many applications, so many kernel modules, IO management, main memory management, all that. So it is tightly bounded. So it is all intervened. So if any of the single application in that kernel application, any of the kernel module in that entire package, it leads to any errors, then the entire application will fail. So the best examples of monolithic kernels are Linux, Solaris, MS-DOS kernel. So all these are the examples of monolithic kernel. Now how it is, you are seeing here, this is the application and monolithic kernel with all operating system services running in kernel space. So all the modules are closely bounded and it is in one common space. So any small error in any one of the module here, it will affect the entire kernel. So this is what is monolithic kernel.